This is Dr. Mohan Lakshmi, Professor and Head, Department of Electronics and Communication Engineering from Rohini College of Engineering and Technology, Kanyakumari district. So, in this lecture, we'll see about the rectifier, which will play an important role in the power supply. So, you can be able to say what is rectifier. You can be able to explain how it operates, and you can also able to classify the rectifier. So rectifier, it is a device which will convert an AC voltage into a pulsating DC. So many of you will be saying it as, you will define it as a conversion of a AC to a DC. It is not a DC, it is a pulsating DC. So it will be using a unidirectional conducting device. So unidirectional conducting device, a very good example is a PN junction diode. So it conducts in one direction. So whenever you learn about this rectifiers, you should be very careful in learning about this various parameters, or you should analyze these parameters: its efficiency, peak value of both current and voltage, and the ripple factor. So what are the types actually? On the period of conduction, so whether it conducts for one half of the cycle or the full duration of the cycle, both positive half and negative half, then it is classified as half wave rectifier and full wave rectifier respectively. So depending upon the connection procedure, this is classified under the bridge rectifier. So half wave rectifier, so there are certain important parameters given. So the ripple factor will be quite high, efficiency is very low, the utilization factor is also very low. So the half wave rectifier circuit is normally not used as a power rectifier circuit. Half wave rectifiers, you can see as a diode conducts in one direction and block in the other. So you can see in the positive half it conducts, or in the negative half it conducts. So one half only it conducts, right? So when connected with AC voltage, diode only allows half cycle of it to pass, and hence it will convert an AC into a DC, that is pulsating DC. As half of the wave gets rectified, the process is called half wave rectification. A diode is connected to an AC source and a load resistor, forming a half wave rectifier. You can see here a diode is there and a resistor is connected, which is a load resistor. So the positive half cycle will cause the current to flow through the diode, that causes voltage drop across the resistor. So the diode as rectifiers, so average value of half wave output voltage, so you can see in the slide, so the average value is given by Vp by Pi. V average is approximately 31.8 of Vp, that is a peak voltage. Peak inverse voltage will be actually equal to the peak voltage Vp. So full wave rectifier, the ripple factor is 0.48. You could see here the rectifier efficiency as well as the TF is high compared to the half wave rectifier, which is 81.2% and 0.693 respectively. So the full wave rectifier, this allows a unidirectional current through the load during the entire 360 degree of the input cycle. So you have both positive half and the negative half, and there instead of 2 diodes there will be 4 diodes. So you could see here two diodes will be conducting at one cycle of the wave, and other two diodes will be connecting in the other cycle. The output voltage have twice the input frequency. So here the average voltage is 63.7% of the peak voltage. So this is again center tapped full wave rectifier, but transformer is used with the diodes to conduct on alternative half cycles. So during the positive half cycle, the upper diode will be forward biased. So you can see here which is mentioned in the blue color and the black color. So during positive half cycle, the upper diode is forward biased and the lower diode will be the reverse biased. During the negative half cycle, the lower diode will be forward, whereas the upper diode will be the reverse bias, which is indicated for the forward bias, it is indicated in the blue, and for the reverse bias it is indicated in the black. So you can see in the first waveform, which is shown in the green color, so which conducts for the positive half, as well as in the second diagram which it conducts in the negative half. So the bridge full wave rectifiers, it is suitable for applications where large powers are required. So the bridge full wave rectifier, it uses 4 diodes which is connected across the entire secondary as shown. So the conduction path for the positive half cycle is shown over here, and for the negative cycle is shown in the second diagram. So this is how the bridge full wave rectifier will work, where 2 diodes will be in conducting and the other 2 diode will be conducting in the next cycle. So the bridge wave full wave rectifier, if you can take an example. So the peak, what will be the peak output voltage if the current is known, and that's all. So you know that it is 1.41 VRMS, so which is 33.9 volt, and the VP can be calculated to be VP secondary minus 1.4, which will be 32.5, and applying the Ohm's law, you could find out what is the IP or the output waveform. So based on this, you know what is rectifier, how it is classified. You can explain the operation of a rectifier. Thank you.